this part is covering the part related to the inter-cell handover mobility, which is mainly based, as I mentioned before, based on event A3 or event A5. So again, this scenario, as I highlighted at the very beginning of today's video, that whenever the user is moving from one, for example, site to another, from one cell to another cell, which is mean inter-cell handover from one sector to another sector. So this required to rely on A3 and A5 events to trigger the handover. And when you are saying A3 and A5 events, this means the user RRC signaling now is being involved. So this means the GNB required to deliver the related event to the user to let him what kind of average RSRP is required to send the measurement report. So based on the measurement report, the GNB will decide which shell is the best cells. But there are two very important pieces of information I would like to let you know. First of all, the inter-cell handover mobility is more about the cell level measurement, not beam level measurement. For example, assuming that the user is moving from this side to another side, from one sector to another sector. So the user need to know what is the cell level coverage, RSRP, not the, for example, beam level. He already know the information of beam level, but he need to calculate out of the beams, different beams, the cell level handover to, for example, decide which one is the best one. For example, assume you are moving from this side to another two sides, which one is here, and assume one in the bottom down here, and both of them had different condition. So the question is how the user will be calculating the cell level measurement for those for these two different sites. For example, assuming here we have 8 beams and the other one having 8 beams as well. So this involving something called cell level measurement, and this is actually will let you. This is kind of parameters will be delivered to the user to instruct the user how to do the cell level measurement to decide which cell is the best cell to be sent in the measurement report from the UE to the serving GNB, which will decide which cell it will going to do the handover towards the target cell. So how this being done? So initially there are two parameters going to be delivered. One called ABS Threshold SSB Blocks consolidation, and the other one called number of SSB blocks to average. And those two parameters can be used during the cell level measurement and the cell reselection. So the user can decide which cell is the best during the cell selection or during the handover. So in case of cell selection, this information will be delivered within system information block type 2 or system information block type 4. In terms of handover, which is our topic today, it will be delivered through dedicated signaling, which is RRC Reconfiguration message, to which will allow the user to do the measurement reporting and to allow the user to do the handover through calculating the cell level measurement. So the question is how these parameters are working and how the user will using these two parameters to decide which one, how to calculate the cell level measurement to decide which one is the best cell. So initially, this you have two parameters. The first one in the bottom left here, in the bottom down here, a scale number of SSB blocks to average. This is like tell him how many blocks or SSB you are going to do the average. Assume you have 8 SSB beam within the cell, right? So if this parameter is set to 2 or 3, this means the user need to do average for 2 or 3 beams or SSB beams. But which beams of the 8 he would require to do? It should be the best one, right? So how the best beams will be decided based on the SSB blocks, based on the other parameter, which is called AVS threshold SSB blocks. So for example, this is a threshold telling him that it's 100 dB. So any of the SSB beams will be better on those SSB beams, will be a candidate for the averaging to decide the linear average to decide the cell level measurement. So assume this one, you have 3 beams better than this threshold, and your other parameter, which is called the SSB blocks to average, equal 3. This means what the user will do in this case. In this case, the cell level measurement is defined as a linear average of the strongest measurement result, which exceed the threshold defined by this particular parameter, which is called EDA threshold SSB blocks. This means this will have a linear average of the 3 beams, so the user will be able to send down the measurement report to the GNB. But what if the user was not being configured of any of these two parameters, okay, as a cell level measurement information, or none of the beam, for example, or none of the beam level measurement, one of these beams exceed this particular threshold, as the second example. So first of all, maybe these parameters will not be delivered at all to the user, or maybe the beams will not, even any of the beams will be achieving the threshold, as this example. So in this example, what will happen? Just the strongest beam will be selected, and this will be considered as a cell level measurement, and this will be considered in the measurement report, which is going to be sent from the UE towards the GMB. So this was the first important piece of information, that how the UE will decide the best neighbor cell for the whatever targets he have. Let's assume he have 3 or 4 sites. So this is, he need to perform this cell level measurement through the mentioned parameters here. The second part and second important information. Assume now the GMB, the UE, is going to be handed over to another one, right? And he already decided that this site or this cell is the best cell based on measurement report. So the measurement report, it should include another important information to let the serving GMB or the user himself understand, to tell the GMB which one with which beam within the beams are the best beam, right? So assume now you have uh, you have 8 beams, right? And the user already decide which one is the best cell based on whatever you have just discussed here. Now there is another important information the user need to know, or the GMB and the user need to know. For example, uh, the handover is going during the execution phase is going to done based on contention free or non or contention based, which means based on dedicated preamble or non-dedicated preamble. And this is another story, that whenever you have additional parameter called RSRP Threshold SSB, and this parameter usually delivered delivered in the RRC configuration common parameters, and the user using this to decide whether he's going to send something called contention. The GMB and user decide based on this parameter whether the handover would be during the execution phase will be done as a contention free or contention based. How this can be done, and how the user will know based on this parameter that he can now initiate a contention free. As you know that usually the contention free require initially some a dedicated preamble to be assigned to the user, so the user will be using this preamble to send it to the GMB to avoid any collision, right? But this is not really, it's the case but not the exact case, because as you remember in the session number 3, as I remember, we have highlighted one important information. Let me bring the picture of this information to let you understand more about what I want to say here. Just to quickly recap as well, as mentioned, this command usually in handover typically try to take advantage of the contention free random access, right, to improve the reliability and also improve the reduce the latency, because the usually the contention based required that might be a lot of collision. The user will be sending through a random preamble, so this is might cause a collision with a different users and so on. So actually what will happen in this case, this is required the target cell to allocate one or more dedicated branch preamble, which are linked to this command. What it means by this command, if you remember, I have highlighted before that during the execution phase, so there will be an information be delivered to the user telling him that each of the SSB beams within the site, for example, is associated with a specific preamble. For example, SSB beam 0 is associated with PRATCH 0, 1, and 2. So the user can use this one for the contention free. But when the user can decide and the GMB can decide whether the user is going to use contention free or non or contention based in this case, right? This is a question. This is actually based on this particular parameter, which is called RSRP Threshold SSB. This would be delivered to the user as well. If any of the beams are better than SSB beams, better than threshold, for example, assume this one neg 100 and you have a beam which is neg 99 and the rest are worse than neg 100. So in this case, for example, SSB beam 1 is being to be used, and SSB beam 1, for example, in this case was associated with PRATCH 3, 4, and 5. So the user will be initiating the handover execution PRATCH using this RATCH preamble, which is associated here. And in case if the threshold are not met, so this means this will be using contention based. So this means the user will be sending a random preamble toward the to using the for during the random access during the execution phase. So this will be using a contention-based, using a random preamble in case if this parameter is being set. So this is actually the meaning of the second parameter, which is mainly used to decide whether contention-free or contention-based are going to be used, and which beam are the best beam is going to be selected on top of the cell level measurement. So the measurement report at the very end, which is going to send by the user, it will contain a cell level measurement, the average of the cell level, and also it will contain the reported best SSB beams within the same measurement report. This is the case where we have it here. Another just aside information, the bottom left comment here. If you zoom in here, sometimes you might need to design your mobility, for example, based on not SSB beams or SSB RSRP or SNR or SRQ. It can also, in some particular cases, based on CSI-SINR. However, I didn't do this or use this part before, but just to let you know that cannot be done unless you confirm that the users in your network are supporting the CSI SNR reporting. How you can confirm the capability? This is an optional UE capability, which UE must declare separately for frequency range 1 and 2 through using this CSI SNR measurement flag. This is in the UE configuration, UE capability message, and you'll find this flag. For example, if it's flagged as 1, this means it's supporting this CSI-SNR measurement, and it will fund it under something called measurement and mobility parameters FRX differentiation. This is actually a side information here. The next and last slide of today's video, it will be about the differences between SINR and what kind of SINR we have in 5G and what is the main differences between all of them. And there's just additional information which I missed to cover in the previous 5 session. Just quickly before moving to the next session, I would like to show you like one particular example when we did the tuning in one of the networks. For example, I highlighted this RSRP Threshold SSB, right? Which is SSB, which is what deciding here whether contention-free or non-contention-based, contention-based or contention-free is going to be used during the handover execution phase or during the handover in general, right? So this parameter, for example, here is the values where you have it, 3GPP values. So for example, here we tuned it, we would reduce the value. For example, let's assume it was 120, we make it 110. So we reduce the probability of getting, for example, contention-free random access, because now it's more difficult. You need the beams to be better than 110 instead of 120 to initiate the user, so the user will be able to initiate contention-free random access procedures. So for example, in this case, we tuned the parameter, we found reduction in the contention-free attempt, and at the same time improving the success rate. And was also the opposite way around in the contention base, where we have seen increase in the attempt, but also there was an improvement in the right success rate. So we get to know, for example, that the parameter value where we choose was the best optimal or the optimum value for this particular network. This was just an example for the this particular parameter, which I highlighted that each SSB beam corresponds to a unique preamble index, which can be used for the contention-free random access procedures. And that's all about today's video. Again, I hope if you like the video to press like and to share the information and to spread the knowledge. And thank you very much and see you in the next video.